The headline says China is banning AI exports, but the engineering reality is a silent pivot in your stack. For years, global developers relied on an assumption of open-weight model availability. Download a checkpoint from any region and run it locally. That era is ending not because models are disappearing, but because geopolitical friction has forced a fundamental architectural shift known as hybrid sovereignty. This isn't about politics, it is about the sudden obsolescence of your current inference strategy. As U.S. export controls on hardware tighten, specifically targeting chips like the A100 and H100, Chinese developers have bypassed these limits not by smuggling, but by engineering efficiency. They are training state-of-the-art models on restricted-tier silicon, such as NVIDIA's H20 GPUs, using advanced software stacks to maximize throughput per watt. The result is an ecosystem that has decoupled from the global open-weight commons you have been building your pipelines around. If your system design assumes continuous access to cutting-edge weights, you are currently designing for a world that no longer exists. We need to debunk a persistent myth right away, that export controls stall AI progress in China. They do not. They force a different kind of innovation. A study from the Berkeley Risk and Security Lab demonstrates how Chinese firms successfully trained massive models like Hunyuan Large using those capped H20 GPUs. These chips were explicitly designed with performance limits to comply with Washington's rules. Yet by leveraging aggressive machine learning optimization techniques, engineers achieved efficiency gains that bypassed the intended technological moat of restrictions. This proves a critical truth for your career. State-of-the-art is no longer defined solely by access to top-tier silicon. It is now defined by software-level architectural ingenuity on whatever hardware remains accessible and compliant. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This shift has created an unintended consequence in the global landscape, accelerating China's open ecosystem rather than stifling it. Facing restricted access to high-performance semiconductors since late 2022, developers there shifted strategy from relying on closed foreign models to embedding open-source architectures into their national infrastructure between 2016 and 2025. The data supports this surge. A recent analysis published in June of 2026 reveals that engagement with large language model repositories by Chinese engineers increased significantly compared to their U.S. counterparts during the post-control period. This has created a robust, self-reliant pool of open weights operating independently of Western hardware constraints. For you as an engineer, this means there is now a parallel universe of AI development happening in real time that your current stack might be ignoring entirely. The regulatory landscape is fracturing into distinct engineering domains where compliance dictates model selection strategies. The European Union focuses on ethics and privacy under the AI Act. China prioritizes ideological alignment and deepfake mitigation, while the United States navigates a mix of federal guidelines and aggressive state-level legislation like California's SB DEG 147. For developers, this means that compliance is no longer just a legal checkbox. It dictates which models are viable in production environments today. You can no longer assume a single global standard for deployment. Your inference pipeline must now account for jurisdiction-specific constraints that determine exactly what you can run and where. This brings us to the core engineering shift, moving from open-weight reliance to hybrid sovereignty. Open-weight reliance was the mindset of download and run, assuming seamless access regardless of origin. Hybrid sovereignty is an architectural approach where inference pipelines are redesigned to accommodate sovereign infrastructure constraints. It prioritizes local data centers and optimized software stacks over raw hardware power availability from foreign entities. Visually, you can think of this as moving from a linear pipeline that breaks if one link fails to a modular system designed for resilience against fragmentation. This shift changes the fundamental question your team asks during design. Instead of just asking about accuracy or latency, you must ask how resilient your stack is when supply chains or political tides cut off specific weights overnight. The career impact here is immediate and profound. Your current resume and system design patterns may be built on the assumption of global open access, but the market is shifting toward engineers who can architect systems resilient to this fragmentation. If you continue designing for a unified global model pool, Your solutions will face immediate friction when supply chains or political tides cut off specific weights or hardware types. You must diversify your model sourcing and stop hard-coding dependencies on models that may be geo-blocked. Build abstraction layers in your inference pipelines that allow for seamless swapping of model backends based on availability and compliance status without rewriting code from scratch. Furthermore, the era of simply buying the biggest GPU to solve problems is giving way to maximizing efficiency per watt. Just as Chinese firms are training top models on H20s, you must prioritize software optimization techniques like quantization, pruning, and distillation that allow high-performance inference on whatever hardware remains accessible. Long-term system design now requires a geopolitical risk assessment component embedded in your engineering workflow. You need to ask the hard question: if this model's source region becomes inaccessible tomorrow due to policy changes, does my stack collapse? The developers who can build flexible inference pipelines that adapt to fragmented hardware and regulatory landscapes will be the most valuable assets in the next decade of AI deployment. The future outlook suggests that one-size-fits-all AI solutions are becoming obsolete. Specialization is no longer just about knowing a specific framework. It is about understanding how to navigate a fractured global infrastructure where your code must survive political shifts as well as traffic spikes. This creates new opportunities for engineers who can bridge the gap between raw computational power and regulatory reality, turning constraints into competitive advantages through better architecture. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.